kids, it's time for you to do what I call big boy lab. I don't know what you call them, but we call them big boy labs. That way you know that they're a lab that is followed by a lab quiz, and we expect a quality data table, conclusions, and graphs and all that jazz.
It's time for you to show all your skills.
So how does distance affect the photoelectric effect is the title.
Okay, so you have your problem statement, our testable question up there. So this should help you very clearly identify your independent variable and your dependent variable, okay? And then we have some background information for you. So if you need to go ahead and pause the video so that you can read through that, you might want to do that because we put it there because it's important for you to know.
Bada bing. Pause now. Okay, so your materials. We've used a ring stand before with the, oh, they didn't do that lab. Okay, so a ring stand is going to be, we don't have one with us, but it has a rectangle base and it has a pole. And like you'll see it in like those like lab like cartoons where the scientists put like Bunsen burners underneath and beakers on top. So you need a ring stand, a clamp which clamps things. Solar panel is a photovoltaic cell, and the rest of the stuff you have used before.
Okay, so before you guys get started, we want you to write a hypothesis, and we have given you the start of a hypothesis. This should go into your science notebook. You just need to finish it with what you think is going to happen.
I do want you, I'm not sure what you make your challenge kits. For my challenge kits, you should have the experimental design diagram. So it's that half sheet where you put in your IV. Do you make the kids do it?
Yeah, the table, like the fill-in-the-blank table that you've had before.
That's what you should do. Okay. Should we have them read the procedures? Can I give them a hint here? Do you mind?
No, go ahead.
Okay, what I want to talk about with the photovoltaic cells, this is plastic. Your clamp is metal. So when you clamp these things together, please be careful with the plastic because metal is a bit stronger material and it could crack these, and we don't have an infinite supply. Okay, and then you'll need to read your own procedures when you do the lab for sure. But when you write your hypothesis, make sure you notice that you're changing the distance between the light source here, and then you're going to see how much current is produced. So here's your procedure spelled out.
One thing you need to pay attention to right away with step 1 is if you connect your ammeter, you need to make sure it's at 0. Remember, if it's below 0, then you need to flip-flop your alligator clips on the back.
Yep, you got your electrons going backwards. That's never good. You might want to try to do this in a science lab or in the classroom if people aren't doing assessments, so you can have a darkened room so you don't have like an extra variable going around here.
And when you set up the direction of your light source, you want to make sure that your light source isn't going to shine on anyone else's panel as well, and that no one else's is shining on yours. So try to face the lab's different directions.
Kind of, I think Ghostbusters, like don't cross the beams.
Right.
I'm pretty sure it's pretty significant. Okay, tips and suggestions. Control all your variables. Extra lighting. The angle of your light and the angle of the panel. Try to make those consistent.
Do a whole trial at a time. So do one trial at 10 centimeters, one trial at 20, one trial at 30, one trial at 40, and one trial at 50, and then go back. Do not do all 3 trials at one level.
20. No, because if you had a mistake, you did that mistake 3 times in a row. And I saw this happen all the time the last couple labs. Doing it all fresh. And then graphing. Make sure you consult your graphing cheat sheet. Know which one's IV, DV. And make sure you don't have double zeros and your intervals are all spaced out equally.
Your cheat sheet is in the front of your science notebook.
Yep.
We gave it to you in the beginning of the year.
Okay, in conclusions, I forgot to write this on here, but we do want 3 things for your conclusion. A claim that answers a problem. How was your hypothesis? You weren't right, nor were you wrong, but you might have been supported or not. And then finally,
evidence to support your claim.
Prove it.